friends, welcome back to the channel. Today we are going to do example number 3, which is very important, has been a previously asked question and most of us leave it, definitely because it is the toughest one, right? So this is the figure that has been given to you. Now look at this figure. In this figure we can clearly see that we have been given a circle. There are two tangents from the same point. We can see that the radius is actually touching a tangent, which means we know about 90 degree. Now we need to do a construction here, which is very simple. You just need to draw an angle bisector. Now what does an angle bisector do? So the work that angle bisector do is that firstly it will bisect the angle, obviously that we know. The other work that it does is that the line, the chord which is coming in between, for an example, it is in triangle. As you can see that here is a triangle, so in this triangle this is an angle bisector. So now what will happen is that this will form 90 degree here, 90 degree here, and this will make this line in halves. So now this PR will be equal to RQ. This is what an angle bisector does. So clearly you can see here that an angle bisector is basically making 90 degree, dividing it into equal halves, and then angle is basically being bisected. That is the name suggests, right? That is what the name suggests. Now let us look at this question. In triangle TPO and angle OPR, we have now we need to prove these triangles. Now this triangle is angle PRO, and this triangle, this big one, right, which is this is angle TPO, and this is triangle TPO, and this is triangle OPT, and you have to be very careful with naming. You have to name the similar angles together. So angle ORP. So by AAA, by two angles we can do this. We can see clearly that angle O is common in both the triangles, because I'm taking, just keep in mind which triangles I'm taking. Angle PT, angle OP, angle OPT. This whole triangle, angle OPT, and angle ORP. So this small one and this whole big one, right? So now we can see the angle O is already common. We can see 290 degrees. 190 degrees is being formed by the help of the theorem 10.1. Tangent is perpendicular to the radius perpendicular to the tangent, and rest we know that because of the angle bisector, this is being 90 degrees. So now we have written these two things. In the AA similarity, we know the triangle OPT is similar to triangle ORP. Now let us look at further what we need to do. Now, since we know that these two are similar, we can say that these sides are in proportion. So we'll write that these sides are in proportion. So we can write that OP upon OR is equal to PT, or we can say OP upon OR is equal to, the question has been, let us look at the question once again. Question is PT or TP. That does not matter much, but still we'll write accordingly. TP is equal to TP upon RP is equal to OT upon OP. So OT upon OP, no concern, because OT we don't even know, and OP is 5, but we don't need it, right? We know this thing, right? From this thing we need PT. So we need PT. We are going to take out PT. We know OP. What is OP? OP is 5. Then we know OR. What is OR? OR is 4. Sorry, OR is not given to us. So OR we need to find by Pythagoras theorem. So I am doing it here by Pythagoras theorem. By Pythagoras theorem, what do we have? We have that in triangle OPR, in triangle ORP, this 5 is gonna be the hypotenuse, since it is in the front of the 90 degrees. So whichever side is in opposite to the 90 degree, that is known as the hypotenuse. So this would be 5 square is equal to 4 square plus OR square. 25 is equal to 16 plus OR square. This will become 9 is equal to OR square, and these are also Pythagorean triplets, so you can, but don't do it directly. It's more beneficial in both to do it like this. OR is equal to 3 centimeter. So now we can write here 3. Now we know TP is what we need to find here, and RP has it been given to us? RP, exactly, it is 4 centimeter, right? Just 4 centimeter. This is 4. 4 5 is 20. 20 upon 3 centimeters is the value of TP. No need to open this fraction. And this is how we find it. Hope you enjoyed this video. Thank you so much. Let's meet in the next video.